Hello, my name is Greg Guerin. I'll be presenting Spark Streaming with Kafka. So as an introduction to what I'm going to talk about today, I'm going to go over the technology stack. I'll talk about the network layout, the security, how it's done on the network, how all of these pieces work together, and also just take a moment to talk about what more could be done, sort of logical next steps to build on top of what I did for this project. Let's talk a little bit about the technology stack that's being used. So Spark Streaming is the core technology that this project revolves around. It's similar to Hadoop. The main difference is it does things in memory, whereas Hadoop does a lot more things on disk. Kafka is a publisher-subscribe messaging system. One of its greatest features is its ability to scale. Cassandra is a NoSQL database. Again, it provides the ability to scale out to large amounts of data. Amazon S3, in the context of this project, I'm using S3 much like you would use HDFS when using Hadoop for the file system. Rails, I picked Rails as a web server, not because it's the only web server that could do this, it's just one that I've used before. And HighCharts is a fairly well-established JavaScript library. It has a lot of built-in graphs and charts, and was a pretty good fit for this project. Before we start looking at Apache Spark Streaming, it might be helpful to first look at Apache Spark, which is the core product. Remember, Apache Spark is sort of like Hadoop. It's just faster and a lot easier to use. With Spark, you get an interactive console if you want to just try things out. You can also use Python as one of the languages to interact with it. So to start the Python console, you can just type PySpark in the binary directory and it will start up. And then we can just sort of try something out. So let's do a word count example. So we'll import an operator from the library called add. This is just a simple function that will add two things together. We can read in a file from S3 very easily. This is the complete work of Shakespeare. And now on one line we can basically do the whole word count program. So I'll take everything in lines and I'll do something called a flat map, which all that does is it splits every word by a space into its own element. And then I map that. I map the word with the number 1 as the key value, and then I just reduce by key. And I add all of those words up. So now if I want to look at my results, I can just say .collect on counts, and Spark will go to work. And as you can see, it won't take very long for it to finish its calculation. Done. And now just to look at the result, there it is. So this is just to show that it's very easy to do things in Spark. A couple lines of code. Granted, Python makes it look even simpler, but again, that's one of the tools, is Python is a language that's available. Even when doing Hadoop streaming with Python, it wasn't that easy, and it didn't finish that quickly. So you can see Spark is a real advantage in that sense. Again, Apache Kafka is a publish-subscribe messaging system. It's very good at scaling, which is what we want because we're going to be using this as our input source for Spark Streaming, and we don't want any bottlenecks. So the first thing you have to do when you start a Kafka server is you have to start a Zookeeper service, which what Zookeeper is it's another service that runs, and it's in charge of coordinating clusters. So you'll see a lot of different projects use Zookeeper currently. It's one of the standards, and it just manages having a bunch of servers that are doing the same thing, and it keeps track of who is alive and who is not. So we can look at the Zookeeper configuration file here. You'll notice that it just sets the data directory and the max number of connections. It's set to 0 right now, which actually means unlimited. This is only because it's development mode. In reality, you probably wouldn't set it to unlimited in production. So now we can start the Zookeeper service, which is just this command here. And we point to the configuration file. And it starts up pretty much immediately. So once Zookeeper is set up, then we can actually start the Kafka server itself. So again, I just open up another window, log in, get to the root of Kafka, and let's look at the Kafka properties file that we're using. The first thing you'll notice here is that we have to set the advertised host name. This is when producers and consumers want to connect. This is the address that they'll connect with. If you don't set that, then it's set to its local host, and no one will ever see it from the outside. There's a lot of properties here, but here at the bottom we have the Zookeeper machine and port that we're gonna point to, that's gonna help coordinate everything for us. So now we're set up that we can start the Kafka service itself. So again, we point to the configuration file that we just looked at, and it is started. So now we can actually take a look at what Kafka is actually doing when it is running. So let's log in with another window here. Get to the root directory, and we can just start a consumer here in the command prompt. It's one of the convenience programs that Kafka provides. So we'll say what Zookeeper we want to point at, and that's the one on the local machine. And then we'll say the topic that we're interested in looking at, and we'll pick topic 1, which is one of the ones that we're using for our project, and we'll say give me everything from the beginning of this topic, because Kafka will store things for a given period of time. And as you can see, it has a playback feature, and you can look at everything that it's done, which is super convenient. We didn't use that feature for this project, but it is another feature of Kafka. So this is sort of the core technology that this project is built around, Apache Spark Streaming. Again, it's built on top of Spark. Spark is like Hadoop. This does real-time processing of data. You can use things like Kafka, which I've used, but you can read live streams from Twitter, Flume. You can also read, you can watch directories in HDFS and read those in real time. So let's show what it takes to kind of get a Spark streaming server going. If we log in, and let's cd into our root directory, and now let's start the main service. This is the master node, and you'll see that it shows a log file of where it wrote its logs to. So let's check this out. Let's see, logs. Sorry. The important information to get here is actually this Spark address. This is the Spark protocol with the actual address that we'll be connecting to with our worker nodes, in addition to our programs when we launch them. So now we can start a worker. To do that, we use the Spark class program, and we use the deploy worker class. And here's where we pass it that Spark address that I was talking about. And we can also say how many cores we want it to run on. So we'll say 2. And we're successfully registered with the master node. Okay, so that's all good. Now we can deploy a application to that worker. So what that looks like is, let's log in in a new shell. Let's go to the root directory. And now it's just, we're launching a Java program. And we'll look at this Java program in a little more detail later. But we're setting the class path to be this first market prices jars has all of the Maven jars and all the dependencies. And then this second directory that we're going to use here just has the application jar inside of it. It's nice to separate those out because then when you redeploy, you don't have to refresh the class path. So the name, this is the package name of the program. And that's the name of the class, process trucks. And it takes some parameters. So the first parameter is the IP of the Kafka server. Could be a domain name too, but here again is that Spark address that we'll be deploying to. We use that in a few different places, this being one of them. And the default port on this is usually 7077. Next we pass it the address to a Cassandra server that we want to write to. And then we pass it the topic. All right, so in this case we're using topic 2. And the application starts. It does a lot of bootstrapping in the beginning. And it does also immediately connect to that Kafka topic, and it's building a time window. So for this one, it looks at the last 5 minutes of all the data that it receives. So when it first starts, it doesn't have anything, and it's kind of starting to build up that window of data. So soon here you will see that, all right, so it just received, that was a truncated version of what it received. And let's stop it here. You can see that we have our first sort of map reduce solution here. The keys are country codes, and the values in this case are the number of trucks per country. But the point is, this is reading real-time streams of what's coming into the Kafka. So I currently have the refresh rate set to every 15 seconds. Let's do another map reduce. And the time window is 5 minutes. So every 15 seconds, let's look at the last 5 minutes worth of data and calculate. So again, here's the next 15 seconds worth of information. So